We'll now look at complex rational expressions. So the idea of a complex rational expression is it has some kind of rational expression either inside the numerator or inside the denominator. Put more simply, it's fractions inside of fractions. So an example of this would be something like 1 minus 1 over x all over 1 plus 1 over x. So here we can see that we have a fraction inside of a fraction. We're going to have two methods to solve these, and ultimately which one you use is completely up to you. So we'll start with what we're going to call method 1. The first step in this method will be to simplify the numerator and simplify the denominator. So we'll take this piece by piece. We'll start with looking at just the numerator, simplify it down to get a single fraction, and then do the same thing with the denominator. After that, we just need to divide the two fractions. So here's an example. We're going to start with just the numerator. And we can see that the common denominator here will be a squared. So the first fraction is just 1 over a squared. The second one is a over a squared. So this becomes 1 minus a over a squared. If I look at the denominator, we have the same common denominator. So this is 1 over a squared plus a over a squared, which gives me 1 plus a over a squared. And ultimately, we still have the big fraction. And fractions just mean divide. So I have the top times, and we flip the bottom. We can see that we have an a squared on the top and the bottom. So my final answer, 1 minus a over 1 plus a, which is much simpler. Another example, x over x plus 1 minus 1 over x, all over x plus 1 plus 1 over x. If I start with the numerator, I can see my common denominator is x times x plus 1. So the first fraction, I need to add an x to the top and the bottom. And the second fraction, I need to add an x plus 1 to the top and the bottom. Distributing my negative sign leaves me with x squared minus x minus 1 all over x times x plus 1. On the bottom, I have the same common denominator. The first term needs an x on the top and the bottom. The second term needs an x plus 1 on the top and the bottom. And so this leaves me with x squared plus x plus 1 all over x times x plus 1. So when I divide these, my top fraction, x squared minus x minus 1 over x times x plus 1, and then we times and we flip the second fraction, x over x plus 1 over x squared plus x plus 1. And we can see that the x's and the x plus 1 cancels. On the top, I'm left with x squared minus x minus 1, and on the bottom, x squared plus x plus 1. We'll now look at what we're going to call method 2 to simplifying these complex expressions. The first step will be to find the least common multiple of all the denominators. And it's important that we do this of all, not just the top or just the bottom, but all of them together. And then the second step is we're going to multiply both the numerator and the denominator by the least common multiple. So we'll do some examples to show how this works. So here's our first example. Looking at the denominators, we have an a squared, an a squared, and an a. So we can see that the total common denominator is a squared. So I'm going to multiply both the top and the bottom by a squared. When I do that, 1 over a squared times a squared is 1. 1 over a times a squared is a, so we have minus a. 1 over a squared times a squared is 1, and 1 over a times a squared is a. So we see that we have a much simpler answer. Another one, we can see that the common denominator here is an x times x plus 1, since those are the only things on the denominators. Multiplying the top, x over x plus 1 times x plus 1. The x plus 1's cancel. We're left with an x times an x. For the second term, we see that the x's cancel, so I'm left with 1 times x plus 1. When I move to the denominator, I see that the x plus 1's cancel with the first term. I'm left with x times x. And with the second term, the x's cancel. I'm left with 1 times x plus 1. And once we distribute out this negative sign, x squared minus x minus 1 over x squared plus x plus 1.